All right, so rank acidity using this Ka. So who is the strongest? So strongest have the large Ka value, right? So HBr for sure, 10 to the 9th, right? So which means that when HBr dissociate in water, so this equilibrium favor the formation of the product by 1,000,000,000 times, 10 to the 9, you have 1,000,000,000 times over the reactant. Okay, the weakest one, so some, not the weakest one, but some of them. So we have hydrocyanic acid, so 10 to the negative 10th, which means that at equilibrium, totally this equilibrium favor the formation of the reactant, 1 over 10 to the negative 10th. Okay, real small at the top. All right, if we have to rank it, so HBr the first one for sure, 10 to the 9th, followed by hydronium ion 10 to the 1st, 10 to the 7th. So we said hypochlorous acid, right? HClO. What else we got? Hydrocyanic is 10 to the negative 10th, and the weakest one is hydrogen peroxide. Hydrogen peroxide can act like an acid too, okay, but it's really weak acid. One more time. HBr is a strong acid, while hypochlorous acid is a weak acid. Show the reaction of the two acid with water. Okay, reaction with water. Use an appropriate arrow. In HBr, strong acid, of course, react with water. So totally one-way reaction. Doesn't really go back, right? So it's, of course, it's in HBr is in equilibrium with water, but it's 10 to the 9th. So 99.9999999% of HBr dissociate to hydronium ion and a bromide ion. You can assume that. So that's why I use just the one-way arrow. You can use a reverse arrow. It's fine. All right. I mean equilibrium arrow. All right. Hypochlorous acid. So it's a weak acid, 10 to the negative 7, which means that most of them stay in a molecule. They don't dissociate. React with water. Some of them dissociate. So hydronium ion and then hypochlorate. Okay. One more time. So hypobromite. So BrO minus is a weak base. Write two equilibrium equations. One showing the reaction of hypobromite in water, and the other one showing reaction with conjugate acid in water. Okay. All right. Start with hypobromite with water. It's a base, right? You say it's a base, so this guy gonna accept proton. But well, you can see the structure. This guy doesn't have proton. Totally cannot function as an acid. Gotta be a base. Only proton is in water, so water will donate proton to hypobromite. Hypobromite will become hypobromous, okay? And water become hydroxide ion. All right, so there's a first reaction. Now the second reaction, the other showing the reaction of is conjugate acid. So conjugate acid of hypobromite is hypobromous acid in water. So this guy react with water. Well, this guy react as is an acid, so we will donate a proton to water and go back to become hypobromite and a proton. All right. Let's moving on to monoprotic, diprotic, and poly.